Welcome to the Vishutech, the channel which speaks about the tech language. So, in this video, as we have already discussed, this is a playlist which is started yesterday, and in this playlist, we are learning about the concrete technology. In the concrete technology sessions, we are going to start today part 2. So, in the part 1 up to the concrete gradings concept we have already discussed. If you did not watch the channel or video, so please visit the previous video which is already uploaded on the YouTube channel. So in this video we are going to start from the exposure conditions of any kind of structures. So based on the exposure conditions, we are going to see what will be the minimum cement content, what will be the minimum or maximum water cement ratio, and what will be the minimum grade of concrete. In this concept, let us start from the beginning. If we will see the concrete constructions environmental conditions, so we will watch there is mild, second there will be moderate, severe, very severe and extreme conditions. So there are minimum 5 conditions are there on which we have to discuss. So let us start from the beginning. In the first, if we will see the mild conditions of exposures, so in these conditions we are watching that we have to minimum maintain 300 kg per mq cement. This is most important. In this concept, we have to minimum or maximum water cement ratio we have to adopt 0.55. The minimum grade of concrete for the mild conditions should be M20. In the previous video, we have already discussed and informed about you what is the meaning of M20. So, in the second concept, if we will watch the concept of mild conditions. So, in the mild conditions, the concrete cement will be the same, but the water cement ratio is going to decrease and the grade of concrete is going to increase. Here grade of concrete M20, and but for the mild conditions it is the M25. In the meanwhile, if we are watching this concept, in this concept, as we are coming down, or if we are increasing the cement, you can see over here, if we are increasing the continuously cement quantity, then the cement water cement ratio is decreasing. You can see here this is 0.55 and at the end this is 0.4. Meanwhile, the aggregate the strength of the concrete or the grade of concrete is also increasing. So if we summarize this slide, in this slide what is the actually mentioned, if we are going to increase the cement, then the water cement ratio will decrease and the concept of the grading will increase. So at the final stage, extreme conditions, minimum cement should be 360 and 0.4 will be the maximum water cement ratio, and the grade of concrete will be M40. So in this slide we learned about the exposure conditions of the constructions. So next slide we are going to watch about the PCC, RCC and PSC. What is the meaning of these three terms we will discuss. So you can see over there minimum cementitious material content. In this slide we are going to see what are the conditions over there. These are the values as minimum. So if we are discuss about the minimum cementitious material for the PCC, PCC means plain cement concrete, RCC means reinforced cement concrete, and pre-stressed concrete is the concept of PS. So if we are going to the exposure conditions moderate, so the PCC, for the PCC minimum grade, minimum cementitious material, what is the actual mean of this cementitious material? Actually we are using cement or fly ash or GGBS. These are the binding materials, and these binding materials are basically called nothing but cementitious material. So you have to remember this basic concept for your future and further growth. Further, if we are going to RCC, in the RCC condition, that is the 300, and PSC, pre-stress concrete, that is the minimum cement should be 400 kg per MQ. Basically, there is some typing mistake, that should be MQ, m meter cube. So in the second conditions, this is the severe conditions. In the severe conditions, severe exposure conditions, PCC will be 250, RCC will be 350, and 430 will be the PSC. Extreme conditions, as already I have told you in the previous slides. So in the previous slide we have already said, as the grade of concrete is increasing, the water cement ratio will decrease and the quantity of cement will increase. So in the same, the concepts are there: plain cement concrete, RCC and PSC. What are the minimum cement requirements? We have already discussed over here. These the values which I am discussing over here. This is already from the IAS 456 table, clause number 5.4.5 of CBC. So let us start the next slide. What are we are going to see the next? In this slide, we are going to learn about the maximum cement content. What will be the maximum cement content can be used in any kind of constructions activity. So if we are going to see the cement, then we have to learn about the cementitious material. What is the basic difference between cement and cementitious material? Cement is a single component and cementitious material is the combination of cement oblique fly ash. It may be fly ash, it may be cement, it may be silica fume, it may be GGBS. So you have to learn about the basic concept of this. These are the cementitious material and this is cement. Cement is a binding material and these are also the binding material, but in the cementitious material all will be combined. Okay. Further, let us see what will be the maximum quantity. In this slide we can see over here the maximum OPC cement, ordinary Portland cement, will be used 450 kilogram per MQ. It means 450 kg per MQ is the maximum quantity, not greater than. Always remember, not greater than. Not greater than cement will be used in any kind of cement constructions production. The most important things, as it is already mentioned over here in the slide number same, when fly ash or GGBS, as I have already mentioned, ground granulated blast furnace slag used, OPC's content shall be reduced. So in this concept we can see over there the maximum cement will be used 450 per kg, but if you have to require more strength, then you can go ahead with the fly ash or GGBS, some other binding materials which is most important and widely used in the construction industry. Higher cement content increases. What the coincidence happens if the higher cement content is increases? In this concept we can see over there, if we increase the cement, more and more cement, then the risk of cracking due to dry shrinkage in the thin sections will increase if we are going to use more cement. Second, earlier thermal crack will adopt the place or occurring. Third, increased risk of damage due to alkali silica reaction. We will discuss in a detailed video what is the alkali silica reactions, but what the main concept are saying that if we are increasing more cement more than 450 kg per MQ, then these kind of risk will happen in the structures, and structures may be cracks in several form. Either it may be thermal cracks, or it may be alkali silica reactions attack, or it may be plastic or shrinkage cracks. Okay. In the next slide we are going to see the maximum water cement ratio. These all slides are most important and the most key concept of the civil engineering analysis and architectural view. So as we have already discussed about the PCC, RCC and PSC, in the same conditions, moderate, severe and extreme, we have discussed over there about the quantity of cement, minimum cement quantity. Same on the basis of respectives, if we will see here, we have seen something 250 of the cement quantity, but now we are going to see over there what we are going to see here. We are going to see here the water cement ratio. So water cement ratio for the PC moderate condition is 0.5, severe condition is 0.4, and 0.4 is the extreme conditions. In this slide you can correlate with the previous slide. If you will put the values of PSC, RCC and PCC. So these are the values. If you want to some comparison, let us compare. For the PC there will be 240. For the 240, what will be the water cement ratio is 0.5. Same you can see, if we are going to severe conditions, 250 the minimum cement and extreme 300 mm. So here 0.5, 0.45 and 0.4. In this slide you can correlate these the concept of the exposure conditions. Based on the exposure conditions, you can correlate the values and the most important concept of civil engineering. So next slide is going to be discussed about the culture or phenomena of the concrete, that is nothing but that is related to workability of the concrete. So if we will see the workability of the concrete, what is the workability of concrete? In this concept we will learn about the basic concept related to degree of workability. These are some concepts. Let us start by one by one. Placing conditions, degree of workability, value of workability. So if we are working in shallow sections with vibration, very low workability, and the time cycle on the VV consistometer will be 0.75 dash 0.78. Further, if we are going to working in the light reinforced section with the vibration, that is shallow section and that is light, so workability will be low, and the BB consistometer, the time will be 10 seconds to 5 seconds, and the compacting factor, as it is already mentioned over there, compacting factor will be nothing but that will be 0.8 to 0.85. If we are working in the light reinforced section without vibration, with heavy reinforced section with vibrations, so the conditions are there, you can easily read over there. This will be the medium degree of workability, and the VV consistometer is existing with 2 second to 5 second. Compacting factor is correlating 0.85 to 0.9, and one of the most important, that is slump will be near about 25 to 75 mm. The high conditions of workability, where it will come concrete of heavy reinforced section without vibration. If we are not using the vibrators, then the compacting factors will continuously increase, and the slump value is continue going to be increasing. In this slide what we learn, the basic is that if we are working the vibrators, using the vibrators, so the section will be very low or low degree of freedom, degree of workability, and the VV consistometer will be give some value of in seconds. And the most important in this concept is the workability of these two is very much better than these two. So based on the requirements, if we are working in flow concrete, okay, if we are working in flow concrete, then above three concepts are good. But if we are working in a low or slump concrete, very less valuable structures, so you can go ahead with the slump concretes. So nothing is worried about the concept. It is basically based on your site requirements. Based on the site requirements, all the things are going to be adopted. If you watch this video and if you like the sessions, please like this video and please subscribe the channel. If you are visiting first time or till now not subscribed our channel, Vishu Tech. We are going to get together again on the video number 3rd of the concrete technologies tomorrow. Thanks for watching this video. Thank you so much.